Here we're asked to find the wholes, the vertical asymptotes, the zeros, the horizontal asymptotes, and the domain of this rational. Alright, let's start out by looking at the horizontal asymptote. Alright, first of all, if we notice here, if we look at the degree of our polynomial, on top we have x squared, on bottom we have x squared. So the highest degree for both is equal. So when they're equal, it's just the leading coefficients over each other. So for this one, the horizontal asymptote is going to be 1 over 4. Okay, so it's y is equal to 1 over 4. And so that would be the horizontal asymptote. And again, the reason that is because the degrees here match up. Alright, so now to find the rest of the information, we're going to have to end up factoring. So let's factor the top. If we factor the top, we end up with x plus 3, x minus 2. Okay, now on the bottom, I'm going to do this in a couple steps. I'm going to factor out a 4, so I get x squared plus 16x, not 16x, sorry, 4x plus 3. Now we're going to factor this completely so that we end up with 4 is equal to x plus 1 and x plus 3. Alright, now with this, we're going to find our vertical asymptotes. Now, it's either going to be a whole or a vertical asymptote. Now here, if we look, the x plus 3 cancels out. So when that cancels out, that makes it a whole. So our whole will be at x equals negative 3. That's because this is what's going to make this 0. So that's our whole. Now our vertical asymptote is what we didn't cancel out. That would make the bottom 0 or the denominator 0. So that's going to be x is equal to negative 1. Okay, so now we found the whole of the vertical asymptote. Okay, now our domain restrictions are the same as our holes in our vertical asymptote. So for our domain, I'm just going to say x cannot be negative 3 or negative 1. It can be any other value. Now, so that's our domain. So it'd be all real, again, except these. Now, to find our zeros, we look and see what was canceled out, what didn't cancel out, and we'll make the top 0. So what will make the top 0 is 2. So our zeros would be x is equal to 2. So our zeros come from our numerator. Alright. I'm going to show you how we come up with all this. If we look, there's nothing to factor on top. But to come up with a horizontal asymptote, we don't have to factor anything. Now, our higher degree is on bottom. When our higher degree is on bottom, that means our horizontal asymptote y is equal to 0. Again, that's because our higher degree is on bottom. Now, to come up, so we found horizontal asymptote. Now, there's not going to be any zeros because there's nothing we can put in to make this 0. Now let's look at our vertical asymptote. Okay, to find the vertical asymptote, we're going to factor the bottom, and it'll break apart. This is difference of squares, so we'll have x minus 3x plus the 3. So there's nothing going to cancel out, so we don't have any holes. Now our vertical asymptotes, whatever it's going to be, make the bottom 0 that didn't cancel out. So our vertical asymptote is x is equal to 3, x is equal to negative 3. So these are the two lines that it won't cross. Okay, and then our domain restriction is going to be all real with the exceptions of what our vertical asymptotes are here. So x all real, okay, with the exception of x cannot equal 3 or negative 3. Again, so let's go back to this. Horizontal asymptote is 0 because our largest degree is on bottom. So that makes our horizontal asymptote 0. Okay, our vertical asymptotes are 3 and negative 3 because that's what's going to make our denominator 0. And it's not going to cancel out and be a hole. So there is no hole. So holes is none. So there's no holes and there's no zeros. Because there's nothing that the zeros come from the numerator, and there's nothing that would make the the top part 0. Alright, here, similar process, but we're going to go through this. Alright, first of all, they have the same degree. So when the degree is equal, there is no horizontal asymptote. I'm sorry, the horizontal asymptote is the leading coefficients over each other. So y is equal to 1/2. So that would be our horizontal asymptote. Okay, now we're going to have to factor. The top part, we're going to factor out x out of both of these. But let's look at that. I'm going to do it in steps so we can kind of see it. So on top, I'm factoring out x. I end up with x squared plus 6x plus 8. Okay, on bottom, I'm factoring out 2x so that we end up with x squared plus x minus 6. Okay, now I'm going to break the top part and the bottom part down a little bit more. So we're going to end up with x, okay, plus 4x plus 2. Okay, and then on bottom we'll have 2x and then x plus 3 x minus 2. Okay, because the 3 and the 2 multiplied together give you the negative 6, and then they'll subtract to give you the positive 1 in the middle. Alright, now that we have everything factored, we can go through and start. Remember that it's a hole if it cancels out on the bottom. So here, this will cancel out. So that cancels out. So what's going to make the denominator 0 is x is equal to negative 3 and x is equal to positive 2. So that would be our vertical asymptotes. Okay, now our holes, we still can't let x be 0 down here. So that's going to create a hole. So our hole is when x is equal to 0. Okay, so we've dealt with the bottom part. So we found our holes, a vertical asymptote, horizontal asymptotes, and now we're going to go back to our zeros. Our zeros is what's going to make the numerator 0, but we don't have to, if it cancels out, we're not worried about it. So for the zeros, x is equal to negative 4 and x is equal to negative 2. Now the only other thing we have to do is talk about our domain. Our domain restrictions are going to be the 0, the negative 3, and the 2 because x can't equal those. So all real except, okay, we cannot have x cannot equal 0, negative 3, or 2.